particular lab situation.
Would that be like open-ended response, or is it more of a true-false or?
It's going to be more of a true-false or pick from the list type deal.
Okay.
It's tricky when you're doing a Blackboard to do open-ended like that, just because Blackboard says you have to spell it exactly the same way or it's going to count it wrong.
And then you have to go through and fix all the ones that they spelled one or did a random letter wrong.
Right. So, yeah, most likely it would be like a matching and like pick from the list type deal.
Okay.
It will be, I can promise you, it will only be stuff from out of the lab, stuff that we've seen in the lab.
Will it be as specific, like in the lab there are things that we're asking, which do you think produced the gas reaction?
Yeah.
Which chemical? Will it be that specific?
You know, I just finished grading those here today. That gave some people some trouble. And yeah, we have not talked about that in great detail yet, and I totally understand that. It won't be to that level of specificity. It'll be more general than that.
Okay.
Yeah. Cool. Love it. Preguntas. You guys are looking. You want me to throw some out, and you guys can take a stab at them? What do you think?
Sure.
Sure.
So if I said baking bread, is that chemical or physical?
Chemical.
Chemical. Okay, Isaac, is that endothermic or exothermic baking bread?
Can you repeat the question?
You bet. Baking bread, you said it's going to be chemical. Is that endothermic or exothermic?
Wouldn't that be endothermic?
Yep, putting heat energy in to make it bake. Good. All right, freezing water into ice cubes. Physical or chemical?
Physical.
Physical.
As physical, water before, water after. Exothermic or endothermic? What has to happen to the water to turn into ice?
Exo.
Exo. That one's kind of tricky. When you start looking at phase changes like that, heating up, you're like, okay, endo, I got to put heat energy in to melt stuff. To freeze it, you got to do the opposite. You got to pull heat energy out. So it's exothermic. It's weird because it's not doing it itself. We have to make it do it. So we've got like a refrigerator. It's a heat pump that actually sucks the heat energy out of stuff to make it freeze. All this extra bonus.
Could you quick go over the differences between endo and exothermic?
Yep. Exothermic, if it is an exothermic reaction or an exothermic process, that means that the energy is leaving the system. Either heat, light, whatever the energy might be, the energy is leaving the system. Example of this is like if you light a match, a burning match would be exothermic. You've got a system and it's giving off energy, giving it out. When we start looking at physical changes, melting, freezing, stuff like that, to make your particles move faster, you got to put heat energy into it. So like solid to liquid, ice to water, you got to heat it up, you got to put heat into it. Endothermic is putting energy in. Exo's out, endo.
Okay.
So then if we want to go from steam to water vapor, we got to go the other way. We got to slow down the particles, we got to cool them off. So we got to pull energy out. So that would be exo. Yeah. Glow stick. Chemical or physical?
Chemical.
Chemical. Exo or endo?
Exo.
Exothermic, giving in this instance light energy out. Absolutely. Also, I went to a concert this one time and they were like cutting them open and like putting it on their skin. They're supposed to be non-toxic, but I still don't do that. Safety tip of the day: don't do that. Because then it would quickly fade away. I'm like, that is just getting absorbed through your skin right there. That is ruining your body. So, yeah. Okay.
What would milk be?
Milk what? Aaron, good to see you, man.
Because there's homogenized milk, or how do you pronounce that? Does that matter? On the
homogeneous?
Heterogeneous mixture, solutions, elements, or compounds.
Yeah, sometimes we interchange homogeneous with solution.
Okay.
So we kind of use those interchangeably because a solution is a homogeneous mixture. They're kind of one and the same. Milk would be a homogeneous solution. You know that there's a bunch of stuff in there. You just can't see it.
Okay.
Yeah. Let's see. Glow stick was exothermic. I like it. Dry ice subliming. Ooh, sublime. Remember what that was?
Physical.
It's physical change. What does that mean to sublime?
Change from a solid to a gas.
You know, example. Anybody? Example?
Dry ice.
Yeah, that's freaking awesome. I love it. I need to bring some in for class. Ooh, that'd be fun. There's some really sweet demos you can do with that. Anyway, yeah, so that would be physical, endothermic or exothermic.
Endo.
Endothermic. You got to put heat energy into it to make it turn into that gas. Cool.
Okay.
All right, questions there?
Nope.
Are you doing okay? Isaac, you doing okay?
What's that? My computer just like froze up and I couldn't hear what you guys were saying.
That's right. We just hit the sublime one. You okay on sublime sublimation?
Yes.
Okay. Aaron, you doing okay? I might be working.
Yeah, sorry. I have my mic muted.
Oh no, you're fine. Totally fine. Do you have any questions?
No, I just kind of joined just to see what was going on.
Okay, totally cool. Super chill, totally informal. Just taking questions. If there aren't any specific questions, I'm just throwing out just some random examples just to practice stuff. So.
Okay.
Yeah, got questions? Feel free to chime in. Totes, no pressure. Totally chill. Cool. So intensive, extensive. What was the difference there? Erica, you can't answer.
So what's that website on the board?
Website on the board is if we get a whole bunch of people all in at the same time and people are having trouble getting their questions asked, it's a spot you can post questions.
Oh, okay.
Yeah, and that link is also on the Blackboard site under the announcements page.
Okay.
Rafi, good to see you.
I don't know if anybody can hear me or not.
Gotcha.
Okay, perfect. You guys can hear me.
Yep. All right, so intensive versus extensive?
Intensive is like required. It's irrelevant of sample size, right?
Good. Extensive there. 4 is...
What? Yeah, it's relevant to that.
Does depend on the sample size. Good. So density, intensive, extensive?
Intensive?
Intensive, I like it. Aaron, red. If I said my shirt is red, that would be...
What?
If I said my shirt was red, would that be intensive or extensive?
Intensive.
Intensive, good, I like it. Isaac, if I told you that the chair was 40 inches long?
That would be extensive.
Extensive, specific to this chair. If you got a chase chair, it would not be the same way. Good, I like it. Erica reacts with water to release heat.
What's the question?
Intensive or extensive?
Reacts with water to release heat.
Yep.
Intensive.
So it doesn't matter how much you have, it's going to react with water.
Yeah.
Good example, this sodium. I should have brought stuff down. Sodium. We will actually see that demo here this year. Take a little sodium, throw it in water, burst into flames. Love it. Rafe, malleable?
Malleability, that's intensive.
Yeah, so it's, ooh, this is a good one. Sorry, Aaron, you're going to get put on the spot a little bit. Aaron, if I said surface area is 20 millimeters squared?
Extensive.
Good. Depends specifically on the sample size, depends how big your surface area is. Good, I like it. Isaac, if I said it's a physical or a chemical property?
What's physical or chemical property?
Just if I said any physical property or any chemical property, would that be intensive or extensive?
Intensive?
Intensive. Doesn't... Rafi, are you taking pictures over there?
I have no idea what I'm doing.
That's
I'm so
awesome.
confused.
It's okay.
Breaking things.
No, that's right. You're all good. That's the fun of this. Like, just getting used to the program. It is a different program. I'm just glad it's working because when we tried it in class, it was not having it. So that's exciting. But yes, if I said the board is white, that's a physical property. That is intensive. If I said paper is flammable, that is chemical property is intensive. Doesn't matter how much you got of those. It's going to be the same. Cool. Erica, flammability?
Intensive.
I just gave that away. I'm sorry. That was awful. Yeah, it's terrible. How are we doing? Intensive, extensive? Questions there?
Nope. I feel like that's gonna be the easy part of the test.
Oh, okay. Well, what do you think the hard part's going to be?
I mean, I'm pretty comfortable with what we're learning right now. It's just like I got to get it 100% solid in my mind.
Okay. Do we do some of the boxes? Is that okay? Do you guys see all right?
Yep.
Is that visible or is that too small?
Visible.
Okay. See, in my screen, it's like this teeny tiny, like little. Okay. Let's do. Pyramix? Anybody?
Are you asking pure element? Pure element.
Pure element. Good. Yeah, element or compound. That was a good follow-up question. You said element. Why element?
Because it's not two or more different atoms. They're both one atom.
Good. The
Same type.
Then, you spend a lot of time looking at those diatomics. You gotta watch out for them. Pure mix? Mixture
of compounds and elements.
Pure mix?
Pure compound.
You got it, right? Well, if I told you had a sample of tricky or not tricky?
Tricky.
Tricky, all right. Look, let's do Al2CO3. You guys read that okay?
Yep.
Element or compound?
Compound.
Compound. If you come across something like this, think about those examples we've used in class. H2O, we've seen these before, we call that a compound, two different atoms joined together. Anytime you see a capital letter, that indicates its own element. So in here, how many different elements are there?
What was the question?
Yeah, what?
In this first example here, we said this was a compound, yes?
Yep.
In this compound, how many different elements are there?
2.
We've got Al.
Yep.
These are two different capital letters.
Oh, 3.
Would be, yeah, 3 different elements. 3 different atoms joined together to form. This would be a monster. You want to know? It would look something like this.
The heck?
Right? So, there's 2 aluminums, aluminum, 3 carbons, carbon. 9 oxygens, 1, 2, 3, 1, 2, 3. So, you don't have to be able to do that. That's not.
Okay.
Okay.
I'm just showing you. So, could I ask how many total atoms are in here? So, there's 3 types of atoms in there. Let's do this. How many atoms in there?
2.
Yeah, 2.
Types. How many total atoms?
3.
3 would be 2 hydrogens and an oxygen. So 3
Oh.
total.
Okay.
How many in here? 2 aluminums, 3 carbons, 9 oxygens.
Mm-hmm. 9, 14.
14 total in there. Now, if I told you you had a beaker full of this and you said this is a compound, if that's all that was in the beaker, would that be a pure or a mix?
That'd be a mixture, wouldn't it?
They're all stuck together. They're all bonded just like water. If I said you had a beaker of water, what would you call that?
Pure substance.
Pure substance.
If you had a beaker of this, it would be Pure
Pure
substance.
substance.
This is still a pure compound. If I told you, wow, it's gonna be tricky like that. Sorry, you want tricky or not?
Um,
Do you not care?
not really.
So you have this H2, pure or mixed?
That would be a pure element, right?
Pure element. Yep. Pure element. So that would be a pure substance. If I said, ooh, you have salt water,
That's a mixture.
that'd be mixture. What if I said, ooh, okay, yeah, lake water?
Mixture.
Lake water? Yeah, that's a mixture.
Okay, all that fish poop floating around, right?
Yeah.
So I don't go to the lake because they're all too much fish. Isn't it?
Yeah, we're studying for our chemistry test this week.
I was talking about fish
They
poop.
just-
That was an extreme spot. When you think about the water cycle, the thing is, we have the same water molecules that have been floating around in the atmosphere for millennia. One of the ideas is that you drink dinosaur urine because the water is just recycled water. No, too far, too much. Lake water, that would be a mix. What if I said CO2?
Pyramid? No mixture.
Take your guns.
It's a pure compound, wouldn't it?
Would be pure compound. Alright, let's go back. So this is pure element, this is pure compound. Salt water, is that a homogeneous or a heterogeneous mixture?
Homogeneous?
Homogeneous mixture. We can't see different parts, but we know they're in there. Lake water?
Hetero.
Hetero, you can see the little floaters, right? Or if it's like a really nasty lake, it's got all like the green algae on it and stuff.
Yeah, no, I hate the lake. Like, it's like the worst place.
Right? Well, now you can do boating there. You can't boat in the pool. Or jet skiing. You can't do that in the pool. Let's see. More examples. We did like trail mix.
Hetero.
Heterogeneous mixture. Good. Those are the big ones. The elements, the compounds, homogeneous, heterogeneous mixtures. Nice.
So, are we gonna need to know everything that we basically study this week, like qualitative, quantitative, all the mixtures, compound stuff?
Yep.
Okay.
It is all free game. Anything we've learned this year.
Okay.
Ooh, I'm getting that safety question. Ooh,
We're gonna need to know safety on that one too.
maybe. We've
Oh.
covered it this year,
It's always fun to be safe.
right? So, what do you use to put out a lab fire?
You can use the fire extinguisher, but if it's a person, use a fire blanket.
Perfect. Perfect. If you spill an acid,
Clean it up with a base.
put it up
Yeah.
in the base, and vice versa. I like it. Let's see. What's the order for Bunsen burner?
You first light the match, then the gas.
Match, then the gas. And sometimes, and this is the one that might be a little bit different if I wanted to hit it. If the burner isn't plugged in or like hooked up to the gas jet, hook it up to the gas first, then match, then gas, and then how do you put it out?
And you just turn off the gas.
Turn off the gas. Works out really nice. Just put it out. Well, I like it. What do we use to measure out a set amount of liquid? You guys know what tool we use for that?
Graduated cylinder.
Graduated cylinder, absolutely. What do we use to mix stuff in?
Beaker.
Beaker. What else could we use? Ooh. What else could you mix stuff in?
A flask.
Yeah, totes. Sorry, I'll be right back.
I kind of just guessed on that one.
Well, you're totally a good guess. So we do actually use these volumetric flasks for making up like very specific amounts of a solution. There's this little line Maybe. Can you see the little line?
Um.
Like right here.
Okay.
Yes, no? Are you just saying okay so that I move back from the camera?
Oh no, I can see your finger there, so I'm assuming that's what the line is.
Okay. Ask
Sure.
me tomorrow and I'll show you the little line. So we can actually mix up, if we want to do like a very specific concentration or a solution, we mix those up in, this is a volumetric flask. Have we seen, you may or may not have seen these ones, where they kind of, they look almost like a little bit like a volcano. So I know I'm a bad drawer.
It's a very good volcano.
Right. So this would be, we call that a volumetric, no, take that back. This is a volumetric class. Call this an Erlenmeyer class. Flask would be another choice. Most likely you won't have those two in the same type of question. Cool. How do we measure mass?
Balance.
Yeah, with the balance. What do we
Triple beam balance or whatever.
triple beam balance or an electronic balance? What do you use for weight?
Scale.
Let's see. How does that big stuff? Last thing you ever do in the lab?
Wash your hands.
Wash your hands. Don't take any of those chemicals out with you. Yep. Good. I think all the other safety stuff, I think is pretty well handled. I feel like you guys are going to rock the safety portion.
I got one. Don't stare at magnesium directly while it's on fire.
Right. That was a good one. Wait a minute. Yeah. My fifth hour, we had SSR time in there for fifth hour. So I actually took like a big, super long strip of it, and I lit it for them, and then it like melted part of it off, and it burnt on the table, and I actually like scorched the table a little bit. Yeah. So that's what the tables are there for. They're flame resistant by design. So. Cool. So safety. Talked a little bit about equipment. We talked about pure substance mixtures. Chemical physical. We talked that. Endo exo. So quant versus qual. So if I said there are 24 grams in the beaker, that would be
Qualitative? No, quantitative.
quantitative, intensive or extensive.
Wow. Wait, what was the question?
24 grams in the beaker, intensive or extensive.
Okay, that'd be extensive.
I heard everybody at the same time. I'm gonna have to ask somebody.
Extensive.
Okay, extensive. Yes, would be extensive. If I said that the desks, these lovely little triangle desks that we have, are small, what would that be? Quant or qual?
Qualitative.
Qualitative, intensive, or extensive?
Intensive?
Ooh.
I mean, it could be extensive because it's dealing with like size.
Yeah, because if you broke the desk, it would not be the same size any longer.
Yeah.
Yeah, that doesn't work very nicely. I would probably go extensive. That's meaner than anything you would see on the test. Yeah. If your pop bottle holds 16 ounces, quantitative or qualitative?
Quantitative.
Quantitative, intensive or extensive?
Extensive?
Extensive, depends on that particular bottle. Good. If I said the explosion gave off heat, quant or qual?
Qual.
Qualitative. If I said that the explosion gave off 142 kilojoules of energy,
Quantitative.
quantitative. So we can actually, it all comes down to the tool. If you're just describing it in generality, qualitative. If you actually got a tool that you can measure the caloric heat being given off, then it becomes quantitative.
So about physical and chemical properties, is the burning point, or not necessarily burning point, but, well, I guess, yeah, burning point, is that a chemical property or physical property?
When you say,
chemical, right?
when you say like flammability, you're saying
At what temperature something catches on fire, or something like that?
so you're saying it's combustion point?
Yeah,
That would be chemical.
okay.
Because you're describing how that substance could potentially change into something else.
But when it turns into a gas, that'd be physical because it doesn't change form or
Right.
change properties.
Right. It's still the same substance. It's just now those particles are crazy spread out because they're a gas as opposed to close together.
And then just to double check, whenever you like have a mixture of like salt and water, the solute is the salt and the solvent is the water.
Yep.
Okay.
Yeah. Perfect. Good rule of thumb: the water is your universal solvent.
Okay.
This doesn't have to do with the test really, but what percentage did you say the quizzes are worth as compared to the test?
Quizzes and homeworks kind of go together because this week is a perfect example. We didn't grade our homeworks this week. We kind of checked them together as we went as a class. So then the graded portion was when you showed me the homework results on the quiz. So the homework and quizzes go together. They're worth 20% of our overall grade. Tests are worth 60.
So where's the other 20?
Labs. Yep.
Okay.
And
Okay.
actually, if you haven't checked already, I just got in actually the labs from last week. We're going to get those back tomorrow, and you should also see your quiz score from Blackboard. I've transferred that over to PowerSchool as well.
So yeah, what's the date of the test looking like right now? Is it still Tuesday or?
Tuesday, yep.
Okay.
Yep. We'll have all class period work on it. Yeah. Now we're moving on to measurements.
Yay.
Okay. I'm a nerd. It's okay. Other questions? Just general questions, test questions, life in general?
Could you go over what a compound is? That'd be like C12H22O11. That'd be a compound.
Yeah. Yeah, so compound, anytime you have two or more different elements joined together, we can show it a couple different ways. We can show it. Ooh. How many examples do you want? We can show it a lot of different ways, actually.
I just want like one example.
Okay. So we can show it. Oh yeah. Ooh. Let's do benzene. Benzene. Right? So. Yeah. Okay. So this would be one way you can show compound is just its formula. Two different elements joined together to make it a compound. So one way to think about compound. You can also show that using the ball and stick. Benzene is known in the state of California to cause cancer. Well, actually, to all scientists, benzene causes cancer. So you can also show it. Try and see what it's called. Sounds like not necessary. So there's another way you can show benzene. Kind of makes this beautiful little ring. You can also show it. I see it done this way. We actually will write the letters in. We're showing you all the possible variations.
So are we gonna see on the test actually like drawings of those, or are we just gonna see like the formula?
You'd see just the formula.
Okay.
Yep. This is like second year organic chemistry stuff when you start doing this. But it's good to know it's there. Knowledge is power. But yeah, you'll probably see this one. As opposed to, so this would be a compound as opposed to, if I just said silicon, that would be a number. You may also see compound versus element.
Number 6 on the study guide says a chemical change occurs when a blank and a blank is formed.
Mm-hmm.
What is that?
Yeah, that's kind of mean. So the two blanks refer to a new substance.
Okay.
Yep. That's the dead giveaway for chemical changes if you get something new.
Quick question. How many questions are actually on the test?
You want a specific or general?
Just like a general thing, like 20, 30.
I think all total, I think it's like 25 questions.
Okay.
But if you'd like, I can confirm that. Ooh, actually, I can't. Some students asked if it would be possible to get a synopsis. So I do have just, my screen is just recording in the background. It is me and then your little picture in the corner. Are we okay with that?
Yep.
I was going to wait until the end to do that. I would pull up the test and look at the test, but then it would record my screen looking at the test. And then everyone would be able to see the test if they wouldn't watch this video. So I cannot actually pull that up physically right now. But from typing it up and putting it in, I believe it was about 25 questions.
Okay.
Yeah, and they're going to vary. Going to be a chunk of multiple choice. There's going to be a chunk of chemical or physical, kind of like what we saw in the quiz. There's going to be a section, a little bit of matching, and then a section of kind of what would be best, and then a couple, kind of, if you remember the boxes with the little bubbles. Is it an element? Is it a compound? Is it a mixture? Is it a pure substance?
Okay.
Kind of deal. Kind of very similar to what we saw in HO 1.2 with the letters A through R.
Oh, yeah.
I think there's 3 of those.
Would baking cookies be a chemical or a physical change?
You get the same thing out as you started with?
Kind of. I mean,
You get hard cookies.
yeah.
So if you think about cookies, you got flour, water, eggs, chocolate chips. I think there's baking soda.
But I think there's like oil and butter or something
yeah,
like
there's
that.
oil, butter. Take all those different things, you mix them all together. You bake it, you put heat energy in. Could you take the cookie and get it back to all those individual things?
I guess you would, yeah.
Oh, ooh, can I ask this question? How would you do that?
What do you mean, like?
How would you go, like, if I handed you a cookie and said, get all of the flour out of this cookie?
I guess you would like crush it up and then put water or something.
I would consider that a chemical change.
Okay.
Just because you start with all those individual pieces, you put heat energy into it, and you've actually made something new that has, obviously different properties than just the flour did before, just the oil did before. You got new properties being made. You also see color change.
Okay.
Yeah. That's good. What does density refer to?
Like how close the particles are, and then object or something.
Yep, how closely packed those particles are in a substance. Is that intensive or extensive?
It'll be the same density even no matter what sample size, so it's like intensive.
Good. Would that be quantitative or qualitative? If I said, water, which is super boring, I stand by that comment. Water has a density of 1.00. It's a density of 1. Quantitative or qualitative?
Qualitative?
That's quantitative, yeah.
If I said density of 1 gram per milliliter, it would be quantitative. You did some measurement to get that. We said intensive, chemical or physical density.
Physical?
Physical property, just describing how close those particles are to one another. Good. Trying to think some of those other tricky ones. Density is kind of tricky. Soluble? Ooh. Soluble, if I said, sugar is soluble, is that intensive or extensive?
Intensive?
Intensive. Quantitative, qualitative?
Qualitative?
Qualitative, just general ability to dissolve. Chemical or physical?
It'd be physical, yeah.
Yeah, physical property. We're just describing how well the particles can get pulled apart and put into solution. Now this is where it gets, how much do you want to know? There's a heart tonight. so solubility. There is a spot. There's a maximum amount of stuff that you can actually get to dissolve. That's where we consider it an intensive property, but there is technically a limit. For example, your Kool-Aid. There's a limit to how much sugar you can jam in your Kool-Aid before the sugar just sinks to the bottom.
Mm-hmm.
So, intensive, but there's a limit. Does that make sense?
Yeah.
Cool. Let's see, what else can we talk about?
Could you give some examples of chemical properties?
Sure.
Blanking out on that right now.
So when we look at chemical properties, could be corrosiveness, how corrosive something is. You could say how combustible something is, how flammable it is. Its caloric value, so like when you eat it, how much energy do you get out of it, how much energy is released, would be a chemical property because you're changing it. Obviously, you eat food, you get other stuff out.
Okay.
That we won't go into that other stuff, but you know if there's a change there, and we can see it. So we can describe to what amount of energy do we get out from that food. We can talk general reactivity with just certain substances. For example, how reactive something is with water, or how reactive something is with oxygen, or how reactive something is with heat. Magnesium, prime example, we used it in our lab. It did react with some of the solutions. You know, we dripped the copper sulfate in and we saw it react.
Mm-hmm.
If you put magnesium in just water, nothing. If you heat up the water just a little bit, then it starts to react and give off hydrogen gas. So there's kind of, we could describe how reactive something is just in general with specific substances as well. Does that help?
Yes.
Cool. What else?
I actually kind of gotta go, so
Okay.
yeah, Mr. Jorgen, thanks for your help.
Yeah, no worries. We'll see you tomorrow. Enjoy this weekend.
Goodbye.
And the test is on Tuesday, correct?
Right. So we are going to have more, we're going to have more review tomorrow. I'm actually going to have a PowerPoint that's put together verbatim. These are the types of questions. These are the topics that are covered. These are the pieces that specifically we need to know. So that will be coming tomorrow as well. Yep.
Yeah, I'm gonna sign off as well. Thanks, though.
Yep, not a problem. We're running out of stuff apparently to talk about, which is still fun. Cool. Liquid nitrogen. You guys seen liquid nitrogen before?
I've seen it.
Yeah, they'll use it in medical treatments oftentimes. Very, very cold. Also another one that will sublime. Well, take that back. It's already a liquid. It goes directly to a gas, but it has a very, very low boiling point. I think it's like negative 205 degrees Fahrenheit is when it starts to evaporate. Actually turn into a substance. That's another. Ooh, so yeah. If I said evaporation point or boiling point, is that chemical or physical?
Chemical? Physical?
Be physical. Yeah, that'd be physical because we're not changing the substance. Same substance before as after. Just describing the point at which it does change. Ooh. So what's the temperature for snow to melt?
32 degrees.
Ooh, have I done this in class? Have I done this in class already?
Yeah, maybe.
Okay. 32 degrees, freezing point. When does it start to melt? Oh, we just did that. Starts to melt 32, starts to freeze at 32. So if you were right at 32, are you melting or freezing?
Freezing? I don't know.
Isn't that weird? Really, you could be at that temperature, but it just depends on what the temperature is outside. If it's colder outside than 32, then it's freezing. If it's warmer outside than 32, it's melting. It just kind of depends on what the temperature is outside of it and which way that heat energy goes. If the heat's going in, it's going to melt. If the heat's going out, it's going to freeze.
Okay.
Cool. What else? And do not feel obligated to stay if you don't have other questions. That is okay. Are you guys, what are you most worried about for the test?
For me, it's the thing that think it's the last thing we went over, like mixtures and compounds and stuff.
Okay.
Looking over study guide right now.
You got some specifically on the study guide you want to look at?
What's that?
Are there some on this study guide specifically that you'd like to look at?
So a compound would be like.
Are you talking about the boxes?
Oh yeah, okay, yeah, you already answered that. And then a mixture would be if it was a like compounds and elements, or two different compounds.
Yep.
Okay.
So, I can do it again.
Okay.
It was kind of a short. Here next.
Here.
Pure.
Here next.
Pure.
Mix. Well,
Here next.
is it mixed because that one's bigger than the rest?
Oh, sorry. This one you mean?
Yeah.
Yeah, sorry. It wasn't meant to be that big. I got overzealous in my code.
Pure.
Sure. If I say pure mix,
Mix.
mix of
Compounds.
mix
And element.
of
Or
compounds and elements. Good. Pure mix,
pure.
pure element, pure compound.
Compound.
Pure compound. Pure mix,
Mix.
mix of
Compounds and elements. Compounds and elements.
and elements. Good. Let's do pure mix.
Mix.
Mix
Mix.
of- mixture of
Compounds.
compound. Good. Ooh, all right. Control. I'm just kidding.
Here.
All the groups the same? So it would
Yeah.
be pure element or compound.
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 Pure compound, good. Then let's say pure mix,
Compound and element.
compound and element. I don't know what an element that looks like a triangle. I'm just making stuff up. But still good practice. Cool. More?
No. But a heterogeneous mix would be something like trail mix, and then a homogeneous mix would be something like chocolate milk.
Correct.
Okay. I think I am set for the test, so I'm going to go ahead and
That's
hop
good.
off.
Yeah,
Mark?
me too.
All right, I'm
Thank
gonna hang out.
you.
If anyone else wants to jump in, we'll hit it, and then you'll be able to come back when you're good.
Okay.
All right. You guys have a good one.
Bye.
See you tomorrow.